Hey guys, and welcome back to the NPC series. In this episode, we'll mostly do some background setup for a custom loop structure that we'll utilize a couple times throughout this series, and that you can utilize on your own to add stuff as well. We'll also do some additional preparation for some raycasting that will need to be done in the next episode. If you're unfamiliar with either raycasting or the unit and magnitude properties of Vector 3 objects, then I recommend you check out my videos on those topics, as well as the official documentation, which you can find by simply looking it up. Nonetheless, let's get right to the video. To start this episode off, we're going to work on defining a framework that allows us to create our own custom loops that will run for our NPC, which we can define our own logic for as we create them. If you're confused, then it should hopefully make more sense as we go, so let's get to it. We'll create a new empty table inside the NPC object in base NPC new under the key loops, which will store a list of all the current loops that the NPC is keeping track of. We'll give a new chore to the janitor to clear this table and remove all loops from the memory whenever the NPC object is destroyed. Now we'll move down and create a new function, calling it configure loop. We'll add loop name, properties, callback, and remove callback as the parameters. We will use this function to create a new loop object that will run on repeat when we finish setting it up. The loop name will be an identifier so we can access and later remove this loop. The properties will be a list of properties associated with the loop that it will keep track of and have access to each time it's run. The callback will be a function that's run whenever the loop is repeated and will be where we'll define our main functionality for the loop. The remove callback will be another optional function that you can add that will run whenever the loop is removed, just in case you need to do any cleanup for the specific loop in question. The first thing we'll do is access the loops table we created earlier and index it with the loop name, our loop's identifier. We'll set it equal to a new table inside which we'll add the properties and callbacks for later reference. Now we'll define another function called remove loop, which will take in the loop name for the loop in question to remove. This function will check if a loop already exists by that name in self.loops, and if it does, it will run the remove callback function if there is one. Afterward, it will remove the loop from the loops table to clear it from the lists and from the memory. But so far, these loops aren't any more than data stored in a table, so now we'll set up the loops so that they actually run on repeat. We'll do this by creating a function near the top of the code called __post_simulation. This is one of the default functions in my framework, but it just connects to runService.postSimulation, which is the newer version of runService.heartbeat, and runs once every frame after the physics simulation and whatnot have been calculated. Inside here, we'll loop through the all NPCs table we created inside the module itself to access each individual NPC object. We'll then run a function that we haven't created yet that will be called onPostSimulationLoop for that particular NPC, providing the DT from the postsimulation event, which is the amount of time passed since the last frame. Then we'll scroll back down and define that function under the NPC object using just DT as the only parameter. Inside this function, we'll loop through all of the loop objects in the NPC's loop table, and for each one we'll reference the callback function stored inside it. We'll call this function providing the DT from the parameters as well as the loop's properties table that was specified when creating the loop, just so the loop has direct access to its properties. Now, in theory, if we created a loop, it would add it to the loops list for that particular NPC, and then run the loop's callback function whenever the runService.postSimulation event is fired. Then, if we use our remove loop function to remove a loop, it would no longer be in the loops table, and thus its callback would not be run under runService.postSimulation, as it would no longer be stored in the table. To get a better sense of how this all works, and also just as a sanity check to make sure we did everything correctly, we'll add a small temporary portion under base NPC new, where we'll create a test loop and see how it works. We'll run configure loop on the NPC object, specifying test loop as the loop's identifying name. We'll leave properties as an empty table for now, and then we'll define the next two arguments as two different functions. The first function is going to be what runs every time the loop is run, and it will have the DT and properties parameters provided to it from the structure we set up just a moment ago. The second function is optional and will run whenever the loop is removed using the remove loop function we defined earlier as well. This function only has the properties table as its parameter. We'll add some basic print tests in each of these functions so that we can visually see what code is running when by using the output. Make sure the prints are different from one another so you can identify which is which. Upon running the game, we can see that the loop ran print fires rapidly in the output, but we never get the loop removed print. This is because we never actually removed the loop, so we'll test that now. We'll use task.delay with the first argument being 5 seconds. Inside this task.delay function, we'll run the remove loop function we defined, specifying the same test loop name that we configured the loop as originally. If you're unfamiliar with task.delay, it basically starts a separate thread of sorts similar to task.spawn, where it waits for the specified amount of time in the first argument and then runs the function provided in the second argument after that amount of time. In our case, it will run our function to remove the loop after 5 seconds have passed, but without interfering or delaying any of the code outside of the task.delay. Testing the game again, we can see that loop ran keeps printing repeatedly just like before, but after about 5 seconds pass, then it stops printing loop ran and prints loop removed instead, at which point it stops printing at all because the loop has been removed. Now to test out the properties feature, we'll add a couple properties to the table that we provided as a second argument to our configure loop function call. We'll add a debounce and a cooldown, which we will use to limit the speed at which the loop can run on repeat. At the top of the first function, we'll return if the debounce property is true, and then set that same debounce property to true afterward. Then, at the end of the function, we'll make the code wait for the amount of time in seconds specified by the cooldown property we defined, and then we'll set the debounce property back to false. Normally, these loops are coded to run every single frame, and so the idea behind using a debounce and a cooldown like this is to limit how fast a loop can actually run. The debounce prevents the loop from ever running twice over itself, and waiting for the cooldown gives some space between each time that the loop runs. We can see that it keeps printing loop ran just like before, but now it only prints every half a second, showing that we set up the cooldown correctly. We'll now remove that test loop from our code and move on to defining some more setup for the loops that we'll create in future videos, now that we know our loop structure is working great. If yours didn't work great, I would pause the video here and look it over to see what you might have done wrong. We'll create a function called getDefaultRaycastParams. The only parameter will be include, which is going to be a table of objects that we absolutely want to include in our raycast detection, which will come in handy in later videos to come. In later episodes, we're going to create a loop for player-enemy detection, as well as another for following apart. That enemy detection will have to use raycasting to determine if an enemy is actually within sight and that they're not behind a wall or something. We'll use what this function returns as our raycast params to determine what objects should be and should not be ignored by our raycast later on. We'll also use this function for determining whether or not pathfinding is necessary to reach a certain part so as to save on processing power whenever possible. The first thing we'll do inside this function is create an empty table called all NPC cars, and then we'll loop through all of the NPC character models and objects in self.allNPCs. Inside this for loop, we'll create a new variable called shouldInclude, setting it to false at the start. Then we'll loop through all objects inside our include parameter that we made. Before we can move on, however, we'll need to make sure include isn't nil in the case that the parameter was omitted, since we won't always need to use it when calling this function. We'll do that by setting include, using the same spelling as in the parameter, equal to include or an empty table. Essentially, this will set it equal to the include parameter if it's not nil or false, but if it is nil or false, then it will set it to an empty table instead, allowing us to optionally omit the parameter if we don't need to use it. Back to our inner for loop, we'll check if the current NPC's character is an ancestor of the object that should be included. This would mean that the object from our include list is somewhere inside the NPC character model that we're currently looping through, in which case we'll set the should include to be true and break to end the inner loop. After all of that, we'll check if should include is true or not, and if it is, then we'll insert the NPC character model into the all NPC chars table we created earlier. Now we'll define an exclude list for what objects the raycast param should exclude, adding the current NPC's character to the table to start, as we don't want the raycast to be able to hit the model of the NPC that is doing the detection. Then we'll loop through all of the NPC characters in our table that we created and insert them all into this exclude table as well. Finally, we'll create the actual raycast params object using raycastparams.new. We'll set filter descendants instances to our exclude table and then the filter type to exclude. will now return this raycast_paramps object at the end of the function. Anyway, that will be the end of this episode. If you guys would like to work directly with the code and studio files for any of my tutorials, or just want to support my YouTube channel, then feel free to purchase a membership either here or on Patreon, starting at just $2.99 a month. I offer weekly tutoring services with the higher 2 memberships you can purchase if you're looking for one-on-one help with your projects. Either way though, you're supporting me just by watching this video, so thanks for watching and I'll see you next time.